Hi, welcome back to my video on this radio restoration. I was going to start showing the capacitor replacement, and I noticed something when I was looking at the back of the radio. So let me see if you can get this in. That little script writing there, what that's actually saying is short, so there must be a short in the radio. And I made some interesting discoveries as I was going through it. So we'll go on to that next. But first I wanted to show you is in one of the earlier videos you saw I fixed the speaker with glue. And one of the things when I started doing this very early on is I was always accidentally putting my fingers through the speaker. So it's always a good idea to cover the speaker. I actually made these circles for the different speaker sizes. It's a little more than 4 inches so we can cover it, but I'll just put this on here and tape it up, and this will prevent me from putting my fat fingers through the speaker. And that should be good enough. Good. So now we'll move on to the actual restoration aspect of the capacitors. Move this out a little so we can get the full picture. Good. Alright. So what I generally do is I replace all the existing paper wax capacitors. I replace the electrolytic capacitors, which is this one. And what I noticed is we see a date on here. So this was made in August 8 and in 1946. So this is the original electrolytic capacitors, and they never last that long. So it's no wonder this radio either has a short in it. The other thing I noticed, as I was mentioning, was, let me bring this up a little here. Actually, it'd be easier to zoom in and show. Right here, this is a resistor that looks like it totally burnt out. It's black and it's missing. What I've also noticed is that this right here is, I think it's a replace. Oh, it's part of that. You can see. Is it part of that? No, it's connected. They replaced it with this one because this is not on the schematic, on any of the schematics I looked at. I'm interested to see what it is. I'm going to look at the schematic to see what this should be. I'll measure this to see what this says it is. Also, I noticed that this particular resistor, these are resistors, I said, looks totally burnt out as well. You can hardly see the color, so I'll have to see what that value is. Good. Now we will start to replace. I'm going to replace them all. I'll do a couple live, and then I'll hopefully record the rest of them, but just maybe fast forward through the video, because once you do one, you can see them all. I may not be able to do them all because I am waiting in the mail now from 2 different suppliers for 0.05 MFD capacitors, and they seem to be in high demand because everyone seems to be out of them. So I'll either see how bad the one is that's in there ready and leave it, or I'll put a couple in either parallel or series depending on what I have available, and the actual measurement, and we'll talk about that more later. Alright, so we'll start with this one. This is a fairly easy one. This is a 0.05, so we won't start with that one. There's the other 0.05, so these two are the ones that I don't have. That's funny. Okay, we'll look at this one. 0.002. What I do is usually very simple. I cut at the ends. Okay, you can see this here. And then I use what's called a J-hook. And a J-hook is simply taking the end here and looping it over, and taking the other end and doing the same thing. Some people prefer to go down to where the actual connection is, down here on the pin, and desoldering it and doing it from scratch. I don't like to disturb the existing components. They've been there locked in for 60, 70 years, and generally sometimes you can do more damage by unseating things. So we'll just get that. So this is a 0.002 capacitor. Trying to get that. There it is. I don't know how the autofocus works on this. I'll take my word for it. It's 0.002. And in today's world, you will not have the same actual value. So I'm going to take my 0.0022, which is good enough once I get down that far. One thing about wax capacitors, unlike the electrolytic capacitors, is polarity does not matter. You can put it in either end. However, if you notice on this original one, we have a black line here, right? And this is called the foil. Actually, it says it right there, right? Outside foil. And what you're supposed to do is move the outside foil, make sure whatever you're replacing, the outside foil goes here. And that's kind of to protect it from interference. But these particular capacitors, at least this one in particular, you don't know where the outside foil is. It's not marked. And this is one of the problems of buying some of the cheaper components, which I don't generally do anymore, but I'm trying to go through them. I have some nicer components. They're actually made in the United States, and they have the actual mark on the outside foil, so you'd be able to tell it. So you can build what they call an outside foil sniffer. I've seen a bunch of videos on YouTube, and but it's funny because everything I read, some people say it doesn't make a difference for these older components. Some people say it does. I don't know, but I generally, if I know what the outside foil is, I'll put it in the same direction. If I don't, I'll just guess. I mean, I guess I can do an experiment to do them one way and then do them the other way. I just don't have the patience for that. So let me replace this capacitor. What I like to do is keep the number on top so you can actually see what the value is. So people who have to come back in this radio in 70 more years, if they have to replace this component, will be able to tell. Okay, I'll get my solder and I'll get my soldering iron. Looks like I just move this a little. So I actually see what I'm doing. That's as close as I'm going to get with this. Good, looks good. Get off that little pigtail. Actually, this looks like a cold solder joint. Let me just heat it up again. Much better. Do the other end. Okay, it's a little sloppy, but good enough for government, as they say. Cut off the pigtail. And that's the first one. I'll do one more, and then I'll turn off the video and show you the end results. Okay, this is also 0.002. I guess I should be talking instead of being quiet. These are close together, so I want to make sure we get this proper. J-hook it. Clamp it down. I mentioned earlier that I will be painting this a different color because all the radios are generally ivory white or brown, and I get sick of singing the same way, so I like to paint them different colors to make a little fancier, nicer looking, just to be different. With that in mind, I had to decide on what I'm going to color I'm going to paint it, because when I put in the actual power cord, I'm going to want something that matches. And generally the power cords you can get for these, or they're simply just lamp cords really, they would be either in white, they would be in black, or they would be in brown. And for some reason I always have a little inventory, but I'm out of brown and nobody seems to be carrying those. I can get the black and white ones, so that may be making my decision for me anyway. We'll see. Good. Okay, when we come back, we will see this looking with all the components replaced as far as the paper capacitors. Then I'll show you how I go over the electrolytic capacitor, and also we'll go over testing of the resistors, and in this case having to test resistors. Be right back. Okay, welcome back. As you can see, I did some of these already on the other side. As I was replacing the line filter capacitor, I noticed it goes to the negative of the electrolytic, so I decided I'm going to replace that now as well at the same time. So I just wanted to show you how to do that. Electrolytic, unlike the other capacitors, are polarity specific, so it has to be positive to negative. So the positives come from this side, and if I don't know if you can read this on the camera, but this says 40 MHD for the red and 20 for the blue, and the wires are both red but at the top of the capacitor, and I'll actually show you this. Let me just cut off the old negative. This side's the negative. There we go. Okay. Gonna move these out of here. And these two are the positives. So on this side, you can see a blue and a red. So that's how you know which one goes where. So as I check the schematic, on both my schematics, 40-20 is the proper one. You can see up there. So I will pull out a 40 and a 20. And one thing about these are that it's okay to go higher. I mean, theoretically, if it calls for a 20, you can actually go up to a 40 even higher. So I'm just taking out some capacitors now. I have a 22 instead of a 20 because I really don't make 20s anymore. And this is a 40, just trying to find my 30s. That's a 50. That's a 60. Okay, so I actually do not have a 40. So I am going to move up from a 40 to a 50. And as I mentioned, that doesn't really make a difference in this case. You can go up with these electrolytic capacitors. And you can see these are two different manufacturers. One is actually, one is 150 volts, one is at 250, it calls for 150. Not a problem to do them separately like that. I mean, not separate amounts. And if you look, you'll notice one side is black on both. Let me move it down here. And if I flip it over, you can see silver. Right? And if you follow, on this particular one, you see the pluses here. So it shows you, come on, get in focus. Pluses over here. And on this side, you just know because the arrow goes this way, it always flows from positive to negative. So those are negative. So what I do is I first verify I'm doing it right, double checking my work, as they say. And I will wind these together for the negative. Put it down for now. So just to double check, the 40 is red, which is that one. We'll do one at a time to make sure we don't mess anything up. And I like to keep the end leads as short as possible. Okay, now I can put that one. Good. And then the last one, the blue. Would go to the 20. I'll do the same thing here. I don't want a big lead, so I'll cut it off close to there. Always make sure when you're cutting, if you happen to be cutting over your radio, you see if anything metal piece falls off. You want to get out of your radio because that can cause shorts all over the place and they're difficult to find. So just be aware of that. Good. And I can fit these right back in here. They'll still fit nicely. What I'll do is I'll strip these guys at the end because these are the negatives. So I have to put this one, this one number 2, and this one number 3 from there. It's funny. There it is. And again, I want to keep these as tight as possible. I don't want a lot of overlapping. So I can put that there. Do the same thing now to this one. That one's going to go there as well. Tell you these, one thing about the old wiring with the cloth covered, it really, as it gets older, it really starts to shed. Okay. Some people like to build new items, like to take terminal points and remount them. And if I didn't have the space and stuff, I'd probably do that, you know, something like this. We can connect multiple to one, but this serves a purpose for me. So I'm going to basically just add some solder on the whole string. Dropped a little down in the radio, so I have to look for that. Make sure that comes out good. Everything's connected there. And then the final one will be up here. Yeah, when you have multiple connections, multiple wires going to a single connection, it can get messy. And sometimes those terminal strips are a good idea. But this should be fine for this. It's well connected. This one came off. Need a little better soldering job on this. There we go. All set. Good. So now I'm going to decide. I think because I have 2 of these, and I don't want to have to add 4 capacitors in place of 2, I just may wait for them to come in. So I may not be showing that in the next video. As I wait for them to come in, I still have to replace the electric cord, which I unsoldered from down on this side here, coming out here. So maybe I'll put the cord on as the next thing, waiting for my components to come in. Thank you for joining. I know this was a rather long video, but hopefully it makes sense if you're trying to learn, and for those of you who already know, hopefully you didn't sleep through it. Thanks again. Goodbye.